Right, so today we're going to talk about displacement. So displacement is a scalar quality. So that means it can only be described by one number, right? So your scalar can be 5. I mean that could be your displacement. But for example, a vector quality is described by 2 numbers, right? So 5 meters per second, right? So then you have your 5 meters, then your seconds. Just 5 meters per second, right? You have this is your first number, this is your second number, which is what makes it a vector quality. Alright, so let's go back to what exactly displacement is mathematically. So displacement is S equals initial velocity plus final velocity over 2 multiplied by time. Right, so S is displacement. U is U is initial velocity. V is final velocity. And then T is almost always time. Right? So those are our variables. Let's say that we're trying to find S and U, V, and T. So let's say this is 5. It's about 5. Their initial velocity is 5 meters per second. The final velocity is 7 meters per second. And time is 5 seconds. So we want to find displacement. Let's start with so first we plug everything in. So we have displacement equals 5 plus, I forgot the unit, 5 meters per second times 7 meters, keep making a bunch of mistakes, 7 meters per second plus 7 meters per second over 2 multiplied by 5 seconds, right? 5 seconds. So let's clear things up a bit. So displacement equals 12 meters per second divided by 2 multiplied by 5. So it's simple. Displacement equals 6 meters per second times 5 seconds. That would give us displacement equals 30 meters. So the reason it's 30 meters is because sometimes when you see meters per second, it'll be shown as ms-1. Because as many as you might know, when you have something to the negative first power, then it becomes a fraction. So then m divided by s is the equivalent of ms to the -1. This is also the same as m divided by s. There's a lot of different variations, but they all mean the same thing. So when you multiply 6 meters per second times 5 seconds, the s's cancel out, so you only have 30 meters. You can tell it's a scalar quality or that it's displacement because if it was a vector quality, it would be 30 meters per second. So you would have distance over time, right? But here you just have from point A to point B on a graph. This is how much it crossed, just 30. You're not taking into account any other numbers. So that was easy because it gave you all the numbers and not only asked you to find S. But let's say that it gives us S and it tells us S is 30, but it takes away initial velocity, right? Alright, so then our objective changed. We're not looking for S anymore. We're looking for U. So to find U, we would take this equation apart. So S equals U plus V over 2 times T. So that we're looking for, remember, we're looking for U. So S divided by T equals U plus V over 2 then let's multiply everything by 2. So s over t times 2 equals u plus v. So then 2s over t minus u equals v. Alright, so that's our new equation for finding v. So v equals 2s over t minus u. So let's plug everything in again. Actually, I made a mistake. We're looking for u, not v. So let's just switch u and v. So u equals 2 times s over t minus v. And remember, we already know that s is 30 from the last problem we did. So final initial velocity equals 2 times displacement, which is 30 over 5, so meters per second, minus 7 meters per second, which is our final velocity. So initial velocity equals 2 times, what's that? Which is 6 meters per second. Let's just put it like that. Remember, it's the same thing as 6m divided by s minus 7 meters per second. So let's just do the basic arithmetic, which is u equals 12 meters per second, minus 7 meters as 1. So u equals 12 meters per second minus 7 meters per second, which equals 5 meters per second. But since we already did this problem, we already know that u was in case 5 meters per second. Alright, so we know we did that right. So let's say you want to find v or t, you do the exact same thing. You just take the equation apart and you would isolate the variable you're looking for. In this case, it was u. It might be t next time. So just keep that in mind. And to keep that in mind, if you look at ms, like I was telling you, it's a vector quality. Because initial velocity and final velocity, velocity in general, is a vector quality because it has distance over time. So next, let's talk about velocity. So velocity, like we're just saying, velocity is a vector quality. So to write that, it's final velocity squared, v squared equals initial velocity squared plus 2as. Alright, like we just said, we know s is displacement. Alright? So let's say we have, and a is acceleration. Almost forgot. A is acceleration. So velocity squared equals, final velocity squared equals initial velocity squared plus 2 acceleration times displacement. I don't know how effective that is. So remember, this is a vector quality. So let's say we have v equals 25, actually v equals 5, u equals 3, a equals, I don't know, let's go something crazy, 7, the s equals 15, right? So we would take all of this into account and we would write 5 squared. Actually, yeah, let's look for v. So we don't know what v is. So v squared equals 3 squared plus 2 times acceleration times displacement. So v squared equals 9 plus 2, times 14 times 15. So 14 times 15 equals 210. So v squared equals 9 plus 210. So v squared equals 219. So then we just take the square root of both sides. So the square root of 219 is 14.798. So v equals 14.798. This is where you have to round to the amount of significant figures wanted. So let's say you want three significant figures. So 1, 2, 3. So this is the number we round to. So 1, 2, 3. So V equals 14.7, or most likely this will become just simply 15 if you wanted to round up to this. So it's either you're safe for going with 14.7 or 14.79 because that's a more exact answer in this point, which you want. So velocity squared, or velocity in general, final velocity is a lot easier to calculate than displacement. So then, yeah, those are the two big ones. Right, so good luck, guys.